Yeah, we're live. I'll start our little thing here. So tonight, what I want to do, we got lots of cool stuff to talk about. Just we're going to take a look at different power curves of a couple of different turbos. We ran a GTX 3584 RS turbo and a G42. But mostly what I wanted to talk about was I'm going to show you the power curves of these things. In fact, this thing will end with a demonstration of the power curves. You can see we have the NA power curve down at the bottom there. This one was with a G42. Let's check out this one here. Let's see here. Yeah, there we go. So we got a couple of different turbos. And the thing I want to talk about tonight is there's no audio. I thought that my mic was working. It showed my mic. Can you guys hear me? Chris, let me know. Can you hear me? Can you hear me? Can you hear me? Let me know. Otherwise, otherwise I can reset it up. Okay, we can hear you. Okay, I thought so. I could see the mic movement. So what we want to talk about is our power curve. So if I leave this up right here, we can kind of take a look at that. You can see the power curves on there, and we can talk about, hey, look, this, if we're taking a look at this thing, you can see the NA power curve, and then we can see the various power curves at different boost levels. So if we add boost, you can see, hey, we went from like on the GTX 3584 RS turbo, we went from 630 horsepower roughly after making 430 something. NA, the lowest boost setting was like 635 and kind of the same kind of torque. And then we went to 801 horsepower and 844 foot-pounds. On the bigger G42 turbo, if we take a look at that, we could see the motor was my aluminum 5.3. We had a Trailblazer SS. We had my low buck truck camshaft in it. We had the 1000cc injectors. We had that G42 turbo. Stock exhaust manifolds feeding a Y pipe. We had our little boost controller there. You can kind of see the setup there going in, and we can see. And for some reason, I use the same power curve on both of these, unfortunately. But the thing that I want to talk about is we take a look at we're raising the boost and we have our NA power curve. We raise the boost. The boost curve is staying, or the power curves are basically staying consistent. So this thing is making peak power when it's NA, 6,000 or so. And it basically kind of holds level in terms of power, almost out to 6,500 with that particular camshaft, with the low buck truck camshaft. And the Trailblazer SS had stock heads on it. It was on a 5.3. And we see when we add boost, if we can get the boost to stay consistent, it kind of mirrors that. And so the question becomes, well, Richard, what if I want to, first of all, the question is, do you want that kind of curve? Do you want to be making power at, peak power at 6,000 and have it hold steady out to 6,500? Do you want peak torque occurring at 47 or 4,800 RPM? And this thing made more than, with the G42, it made more than 900 horsepower fairly easily at like 15 pounds. And then it made more than 800 with the smaller turbo at a similar boost level. Excuse me, only because we're getting up near the flow limit of the smaller turbo in that instance, and we're not anywhere near the flow limit of the G42 turbo, the larger G42 turbo. So the question is, do you want to just raise the boost level? That's the first question on a turbo. Okay, we've got an NA power curve. We add a turbo to it. It still has the same NA power curve. It just basically has more of all of that. You could see we went from 400 to 600 to 7, 8, 900 in the case of the G42. Same thing. We went from 400, low 400s to 6, 7, 800, whatever, with the smaller turbo. And we have a fairly consistent curve. Do you want that? So this is why I want to show this to guys. If you have a turbo combination and you've done it right, you have enough fuel, you've got a big enough pump, you've got big enough injectors, you got a turbo that will support the power level that you're talking about, you got an intercooler, we ran this on E85, you got good gas, you've checked off all the boxes. This is what it does. the turbo curve, and this is the way it is with any small block Dodge, Ford, Chevy, whatever. It looks like the NA curve, so it's making power in the same RPM range, and this is important. And we go from 430 odd horsepower in this case up to 900, and we could continue going up to 1200 if you wanted to do that with this particular turbo. The question isn't, do you want to make more power? Because turbos do that with boost. So we went from, 6, 8, 10, 15 pounds, whatever. And if we keep going up to 20 or 25, wherever this turbo will support using our multiplier, but you're still going to have this kind of effective RPM range. Now, I'm only showing it going to 6,300 or something. It would continue to go to 6,500 if you wanted to do that. But this camshaft is designed to make power, pretty good power on these things to like 6,500 RPM. It's a 212 cam. It's not really big. You can see like 1,000 horsepower stuff. Very, very easy, even with this camshaft, because as we know, every cam is a turbo cam. But the question then becomes, well, what if I want a different power curve? So that's where we're changing the NA combination. So, okay, I get guys all the time, I want to run to 8,000. Well, do you really want to? Because the thing that you're going to get is you're going to get like less reliability, and the thing is probably going to hurt itself. But if that's what you want to do that. The way to do that is not with more boost. Now we could talk about having a rising boost curve with an electronic controller. That could help, but that's an artificial thing, and it's not the best method. It's one way, and it is something that you could do as an add-on to doing the other things. So if you want to change this power curve, if you want to make power out at 7,000 or 7,500, you're going to have to change things. And that's not going to be the turbo. This turbo will support umpteen, it'll support 1,200 horsepower. So that's not what to look at. What you need to look at really is the camshaft, and more importantly in this case is the intake manifold. This one had a Trailblazer SS, which is a long runner factory style intake manifold. Makes really good average power production. I mean, even down near 3,000 RPM, we're making 750 foot-pounds of torque. So it's a lot. It's tire roasting a lot. So you have, when the boost is turned up, you have some room to make less torque down there if that's what you want to do. 750 foot-pounds, if you've got a 3,000 RPM stall converter on something and you nail the throttle with 700 or 750 foot-pounds of torque, it's going to spin the tires a lot. And so if you were thinking, okay, well, I could afford to give up a little bit of that, and now I want power to happen out at a higher RPM range, and you want to do that, you put a shorter runner intake manifold, the BTR Trinity intake manifold. So shout out to the guys at Brian Tooley Racing. We are a dealer, by the way, if you guys are interested in BTR stuff. Richard Oldner Performance, where you can go get the turbos that we use in this and the camshaft and springs and all that. We have the BTR stuff. So you could put a short runner manifold like a Trinity intake manifold, an equalizer, a Holley low ram, a high ram for that matter. If you have the hood clearance that you want to put that kind of manifold on there. The nice thing about a low ram or Trinity or others that have those kinds of things, or the Sniper style intake manifold, that fabricated one that's so popular out there, fabricated intake manifold that is still fairly short runner, that will fit under the hood. And a lot of times that's the thing. I mean, I'm sure that's why the guys at BTR sell so many of those manifolds, is guys want a short runner manifold that they can run more RPM with, that will also fit under the hood with a boosted application. There's no boosted intake manifold, by the way. There's just intake manifolds. But if you want to run higher RPM, a shorter runner manifold will allow you to do that. It's going to lose power down low because that's what they do, but it will gain power out at the top and allow you to now have your power peak out at a higher engine speed than we have here. Ideally, you would team that also with some kind of bigger camshaft. So a 212 camshaft, even with a short runner manifold, while it will carry power farther than we're showing here because of the manifold runner length, it's still not the ideal choice. So you want to team it with some other kind of camshaft, step up in camshaft, go from this low buck truck that we have at Richard Oldner Performance, or a truck Norris from BTR or Chupacabra, that style of camshaft. This is we call it a truck cam. It's used in there are hundreds and hundreds and hundreds of these camshafts that have been sold, not just ours, but of all of these things, of all of this style of camshaft that we designate as a truck cam. but lots of people are running them in non-truck applications. It's not a tow cam. It's just a camshaft that makes power in this kind of RPM range. So whether you put it in your LS1 Camaro or Corvette or Chevelle or whatever you've got, S10 is popular. So you put it in that kind of stuff. But if you team the short runner manifold with also camshaft that wants to make power at a higher engine speed along with that short runner manifold, a BTR, hey guys, a BTR hot rod cam or a BTR red hot cam, that kind of thing, to push power out. And there's lots of other cam manufacturers that have stuff that will be able to do that. Push power out farther in the RPM range. What you're doing is the first thing that you're doing, and this is a lot of times guys that do turbo things, they don't ever look at this. What you're doing is changing the effective operating range of the naturally aspirated motor. So we would see a change in the NA power curve, which is why I include this, and which is why I always try to include the NA power output first and then extend it out. And that's exactly what happened. We would now be making power out farther in the RPM range. The horsepower and torque wouldn't be comparable. We would be making more horsepower than we would be torque, because torque's going to drop and horsepower is going to increase at a higher engine speed. And then when you add boost, since we've changed the NA power curve, the boosted power curve is still going to look exactly like the NA power curve, but you've changed the NA power curve, and now the boosted power curve is also going to look different. So again, it would look like this. We would have railroad tracks at different boost levels. It's just that now that we're making with our new combination with a short runner manifold and more camshaft, instead of making peak power at 6,000 or 6,200 or 5,900 or whatever, we would be making peak power at, let's say we're making it now at 6,800 or 7,000, depending on how big of a camshaft we had. And we lost power down low. We're making peak power there. It's not falling off. It's staying, within a certain number of horsepower out to 7,500. And now we have that power curve shape. We add boost to it. We still have that power curve shape. We still have that power curve shape. We still have that power curve shape as we add more and more boost. It's just now we're making power out at a higher engine speed, but you've changed the NA power curve, and that is the secret. In addition to that, so we'll show some more of these videos. Other two things that I want to talk about. Tomorrow, I'm going to have Jeff Smith on. We're going to do an interview with Jeff Smith, and we're going to be talking about the legendary Callaway Corvette, because Jeff was really good friends with John Lingenfelter, and so we have a lot of inside scoop on talking about the Callaway sledgehammer stuff, and even stuff beyond that. After that, Jeff and I and hopefully Carl are going to get together for an interview, and we're going to talk about the compressed air supercharger, because that's not, I mean, people are just seeing it and hey, go, be quiet. People are just now kind of getting into it and being exposed to it. But the reality is Jeff's story on this, when he tested it at Westech, and I was there when they were doing the testing, is probably like 5 years ago. And they had been working on it. We'll talk about all of this long time before that. And there were guys that tried it long ago, probably not quite as successfully, because of the things that have to go into the things that they essentially had to invent and design and to facilitate this stuff, and then the amazing things that go along with it. So I got those two things coming up, and I'm hopefully Jeff's going to try to talk to Carl and see what his availability is, and so we can talk about that. But tomorrow, join me, please, and we're going to talk about the Callaway, the sledgehammer Corvette, and because Jeff did a big story with it and did stuff with the guys from did a deal with John Lingenfelter, and he also has lots of other cool, like John Lingenfelter related stories, because he and John were good friends, and John, as I said, have said many times, like 17 different kinds of awesome. So, but all of that stuff's coming up, so we got some really cool stuff that we're going to be able to talk about. Very cool stuff. So we'll see what you guys got going on. Turbo power curves. I'm early. I'm late. Audio. Yes, we have audio. Good audio on my end. I can hear you. Jet, hopefully you signed out and then signed back on, and hopefully it was okay. What's your go-to assembly lube for new cam lifters, push rods, etc.? Might sit for a couple of months. Anything that's thick. The Lucas Oil stuff is really good. The Redline stuff is really good. There are a few different ones. You just want something that's going to adhere and stay in place. And most of them are really thick and do a good job of that. Fuel for an 8-liter engine. What are you asking about? If that's the power curve of the engine, need to change parts in the engine or fake a torque curve with a falling boost curve. I don't know what you mean. Lunchbox, what's going on? North Wales is in the house. What's the difference between the BTR centrifugal cam versus a turbo cam? You can look at the specs of those two cams on the BTR website and see what that is. You can look exactly at the specs and go, oh, well, this one has more of this one. This one has more of this one. This one has more of this. Is it worth squirting oil on the valve springs when you start to rev the engine past stock? No, that's not a requirement. A lot of times guys do that for endurance racing, though. If they don't have oil going up into the rocker and running over the rocker, because the push rod feeds the rocker, and then the rocker has like a little oil reservoir kind of. It's not designed as that, but it functions as that, because we're like on an aftermarket rocker, you have an area where the polylock has to go into, and so that kind of fills up with oil, and that spills out over because the rocker's at an angle, spills out over the spring, and that helps cool the spring. Some people, if they don't have that or have enough of that, will design oil sprayers in the valve covers, usually is the way that they do it, and it will spray on the springs. And what you're trying to do is, keep the temperature reasonable, because when they're cycling like that, it definitely produces heat. Boost increases amplitude, frequency stays the same. Not Jeff Smith. He's the Jeff Smith. Well, there's another Jeff Smith that drag races, but Jeff Smith is the guy who was the editor of Hot Rod. And I can only vote once. As far as a curve, it is best to add the timing after the torque peak to keep the motor alive. If you're talking about a timing curve, yes. All motors, all internal combustion engines want less timing at the torque peak than they do at the horsepower peak, and they want less timing at lower engine speeds. You add timing with engine speed because you're wanting the expansion to happen at the right time, and since the motor is going faster, you have to initiate the spark earlier for that expansion to happen at the right time. Can you please contact NBC and get your Ninja Warrior footage to upload your channel? That would be awesome. I think I have stuff that Lisa took while she was there. I'm struggling with my centrifugal cam on a Torxstorm. Made 584 with a centrifugal truck cam, and other guys are making 750 with a TSP NA cam. There's something else there that's not cam related. You don't have 116 horsepower that's because of the cam. You have something else going on. You need to look at other stuff. You need to look at the speed of the blower. You need to look at your NA power curve. You need to look at your timing. You need to look at lots of stuff. 6-liter LS3 heads, 10.4 to 1. What kind of fuel are you running on that? There are many of us. Any idea what size turbos can be best on an L83 to have them spool at 1700? Gated at like 3 psi. How are you going to get them to spool at 1700? And it would be better just to use one if you're wanting to do that. I mean, is this an automatic or a manual? What are you trying to do here? I ordered your dual ball bearing. Do I need to run an oil restrictor? I don't know. Ask Jimmy about that. E85. So you should have enough timing. What kind of timing are you running on that thing? Is it intercooled? How fast are you spinning the blower relative to these other guys? Wasn't John driving the Lingenfelter Vets for Motor Trend top speed tests back when they still did? John always drove his Corvette when they did the top speed shootouts. Looking into the TSP Mad Max cam, 228, 232. Are you sure that it's a 550, 500 lift? It seems odd that it would be a 500 lift. Should that say 550 lift on both of them? What power output would you expect in this cam over a Truck Norris? Same power at a higher engine speed. I'm sure that's a 550 lift. So that cam is not too far removed from a sloppy stage 2. So if you take a look at the videos that I have, the Sloppy Stage 2 made more peak power than a Truck Norris did, but less power probably below 5,000. You have 25 degrees of timing in it with E85 at 8 pounds of boost. Seems like quite a bit. What does the inlet going into the blower look like? And are you running the same size blower as those other guys have? Did you run your motor NA? What's it doing? The GTX 3584 RS is on boost at part throttle, so it should spool quickly. Yeah, that turbo will definitely spool fast. Air cooler, small pulley. It's running timing advance. Some seem to be setting timing locked at 22. What are they doing that on? Yeah, Thomas, I thought it was a 550 cam. Last one I remember was 226. Figured he was always driving. He drove the Sledgehammer too. It was tuned by Red Zone and Antioch on chassis. Yeah, that doesn't mean anything to me. I don't know who people are or what they. It doesn't matter who it is. It just matters what the air fuel and the timing was, and then what the boost was, and whether there's a restriction and all of that. Do you know of any 4-valve per cylinder pushrod engines? Yes, I do. Ilmor made them for Indy. They were outlawed because on the pushrod engines, according to the rules, pushrod engines could run more boost, and so they made ones that were pushrods that were about this long. Do a dive, do a deep dive on the Penske Ilmor engines for and they won and were on pole and all of that because they allowed some of the pushrod engines to run more boost in Indy because they weren't dedicated race motors. This circumvented that. It really is amazing. Didn't run at NA. So yeah, I need to know what and let's see, 8 pounds of boost, and what was it making at the tire? Let's see here. $700 at the tire on a 6-liter with a ProCharger at 8 pounds of boost. Something seems off there. $230 at 50, 540 lift, 112 can be adjusted. Big cam for a 544. No, those had fairly high, fairly long duration. The modular motor cams did. I think that even that. I think I have my comp book here. Let's see here. I thought that even the small modular cam was 220 something. Yeah, a 230 cam is a middle cam for the 4-valve stuff. They got 238s, and the small one's 220. And the 2-valve stuff, those are XFI cams. 229, 237, 245 at 50. The ones that I tested, no, those are NS. We don't care about NSR cams. Yeah, 3 valves, we don't care about those. Even the 262 cams, 226, 230, and then 234, 238, and 242, 246 for the 278 cam. So those have a lot of duration. There. We see better turbo response or more low-end torque and boost with an electronic boost controller and a wastegate over a spring style, or does the electronic wastegate give you better control? If the wastegate is closed, whether that's done electronically or with boost pressure or whatever, if the wastegate is closed, an electronic controller does nothing. The thing that determines, with the wastegate closed, the thing that determines boost response is the turbo size and the NA power output. Once you get past that, then electronic controllers do things. The one thing an electronic controller does is, as without one, if you don't have boost going to the top and bottom of the gate, electronic controllers will hold the gate closed. Sometimes the gate doesn't stay closed if you just have a reference line going to the bottom of the gate, which controls the boost. So what happens is, under boost, the valve starts opening already a little bit. It's open all the way at whatever boost you have it set at, whatever the spring is. Like, let's say it's a 7-pound spring, so the gate's open all the way at 7 pounds. Well, at 2 or 3 or 4 pounds, it might start opening up a little bit early. And with an electronic controller, it holds that closed. And so in the range, as this thing is spooling up, in that range, it can help that little bit of curve right there. But a lot of people think that electronic gate adds, like, improves the spool rate of the turbo. Well, the spool rate of the turbo, like I said, is NA power output and then the turbo sizing. And then the controller can help a little bit in that range. Camshaft BTR 223, 240. Centrifugal supercharged cam 113 plus 5. Built 5.3, 215 heads, Truck Norris cam, twin 66s. Which manifold do you recommend? Holley Hiram or Carbon PTR? Or will the cam run out of RPM? Well, I don't know what you mean by run out of RPM. What is your desired RPM range, which is perfect for what we're talking about today. You have to tell me it's not going to run to 10,000. It's not going to run to 8,000. But where do you want it to run to? What is your desired RPM? And then we'll help you get there. Where would you say an electronic controller comes into play? I would say it's beneficial all the time. It's just that there's nothing an electronic controller can do when the wastegate's closed. An electronic controller can only open and close the wastegate. That's it. So it can't improve the spool rate of the basic function of the turbo size and the NA power output. It can only hold the gate closed. If it's closed, it's just a function of the amount of exhaust flow that it takes to get the turbo spooled up. The controller doesn't affect that at all if the gate's closed. What it does is helps keep the gate closed under those circumstances where I was just talking about. What fuel was this was all run on this turbo setup, was all run on E85. You want 7,500. So you're going to need, I would have for 7,500, if you want to make, let's say you wanted to make peak power at 7,500, I would have a different camshaft than that. And then either the Hiram or the Carbon PTR will allow you to make power up there. Have one 6-liter rec port carb big cam 150 nitrous. Building a 6-liter rec port EFI with an S485. Really want it to be smooth, idle, and drivable. LS9 cam or another suggestion? Yeah, I wouldn't pick an LS9 cam. I mean, I think it'll be drivable, but I like, how much, Kyle, how much power are you trying to make? I wouldn't, for a street driver or whatever, if that's what it's going to be, and it's not going to be a race car, I wouldn't pick an S485 and I wouldn't pick a T6. So tell me more about what you're doing with that. Unless you already have it, then I would definitely pick it. Like Terminator X versus stock ECU, what do you suggest for an LS Swap S10 plan to do turbo in the future? For me, I only want to do an aftermarket ECU because it's so much quicker to be able to tune it rather than try to change the tune on a factory ECU. That being said, you can have both of them do what you want. It just takes a lot more work on a stock ECU. In my opinion, 7,500 is a good RPM for most normal engines. 8,000 plus is Coyote. 9000 K24 or cammed Coyote. Okay. I mean, a Coyote engine isn't designed to run to 8,000 RPM. A stock one isn't. We know that they'll do that, but that's not where the factory wants them to be run. Might explain my confusion of why anybody cares about custom firmware with a boost controller. These new C8s would be so good with twin turbo setups. I think guys have them out there already, right? Doesn't Lingenfelter have one like that? Curve's got the train track look. Yeah, that's typical of boost stuff, is that if everything's right and you're not making big changes on the air fuel and big changes on the timing, and then you're just raising the boost, this is what happens. They just do this. They just make that. And yeah, see, I disagree with mostly all of that. 9,000 RPM K24. That's not where I would tell people to run it, since the factory wants it to run it at 6,500. So an extra 3,000 RPM is, you can get it to do that, but that's certainly not the norm. And again, a K24 curve would be more like this. I mean, it would be 6,500 or so, and then more than that if you had a short runner intake manifold on it. But guys, I remember guys with the B series stuff. Oh, we run mine at 10,000. I'm like, oh, that's great. I set lots of records at between 8,000 and 8,500. Gen 3 LS running forged rods and pistons. Would you leave the stock crank? Yep. Forged crank preferable. I read the stock crank is pretty strong. We've run lots of them with lots and lots of runs, up to 1,500 horsepower, and the stock crank is fine. If you want to put a forged steel crank in it, you can. You're just getting the limit. I don't know how much power you're trying to make, but if you're trying to make 1,500 or something, you're getting to the limit of the stock block and the stock crank and head sealing and all of that stuff anyways. They're all going to be in that range. And it depends on how many passes you want to make at that higher power level. Add to the stage. On K24, you can change the oil pump. Yeah, I know. I've been through all that. I mean, I wrote a book on K series, so I'm familiar with them. I know the balance shaft, and I know the oil pump and all that, but that's still not. We ran ours to 8,000 a lot. And I think we ran the Coyote, the Gen 1 Coyote that I had. I think we might have gone to 8,000, but it's not. We were doing, even when we did the cams and ported head and stuff, unless we put a really short runner intake manifold on it, it didn't want to make power out at 8,000. I miss the techno music. Yeah, it's that's copyrighted now, so. The weird noise is probably the fan in the background. I have the fan going because it's really warm here today. It's like 80 something today, I think. Yeah, it was 86 today. It was nice. First time seeing the channel, almost left. Then you mentioned the K series. I've done lots of K series testing, and I have a K24. In fact, it's over at Skunks awaiting a big bang. Music got purchased by a publisher. Yeah, I think that the copyright stuff happened after I started doing that. There's a weird noise. Yeah, that's probably the fan. Is a 4-inch stroke okay with a positive displacement blower? Yeah, it's fine. I don't think you need that with a, like, you don't need to combine a stroker with a positive displacement blower because you have all kinds of low speed power anyway, but you know, it will work. Southern California weather. Yeah, I'm in Northern California though. At what point do you need to run 2 blow-off valves? I don't know what the power level would be. I've seen guys do that, but I've never done that on any of the ones that we've done. 92 degrees in Florida. That's pretty warm. I know I want to go back to Florida. I want to do some, I need to shout out to the Python Cowboy. I watch his stuff all the time. I was just taking a look and see he does tours, and we may try to take him up on that. And because he can go out because he's licensed. He can go out into areas that we can't access because we're just driving roads and walking into the swamp, and I don't know, all of that's ideal for finding pythons. He also does the iguana stuff because that's also an invasive species. So who knows? But I do want to get back to Florida and try to catch some stuff. I want to do my best F1 Indy impression. So you want it to sound like that? You want it to sound cool? So let's do this. Trailblazer SS. This is a really simple motor. I mean, you could, you know, pretty easy to duplicate. Any kind of, like, this had a low buck truck camshaft, but any kind of camshaft that you're putting in it is fine. And then, you know, it had stock heads, just had springs on it. We had our 9 heads on it. And then a small turbo if you want to make low boost, and then a big turbo if you want to make bigger boost. It's all good stuff. I really would like to run the K series again. That would be kind of cool. I need to put it back together. I think we took it apart to put ring gap in it, and then to put ARP head studs on it, so that we could run boost on it. I really kind of want to run. I think we only ran it up to 600 or something like that, but it was fairly low boost. But it was the same kind of thing, railroad tracks. Northern California is probably like Gold Coast weather. It's nice here. I mean, it gets cold, not cold, like, you know, you'll get in the 40s sometimes. We have gotten snow here. We get hail here. But that's a rarity though. Like I said, 40s, you know, sometimes it gets freezing overnight. You go outside in the morning and your windshield's all frozen over. And then it does get hot here. It gets, you know, 3-digit stuff a bunch. It gets what would be the outcome if diesel fuel is injected into a gas engine that was running when it was under boost? I think that the I don't know what the detonation threshold is of diesel fuel. I would think that it would detonate. 50 in Northwest Indiana. That's still boost weather. Have you tested a ported Trailblazer SS? I have not. I don't think you'd see too much on a mildly built motor, just because, you know, it's all about the needs of the motor. Does the motor need a whole bunch more airflow? We know that those Trailblazer SSs, you know, we've made, I don't know, certainly 550 horsepower. And so, you know, at 450 horsepower, does porting really help that much? It's like testing ported heads. You know, we tested the ported LS3 heads on a kind of stock motor, and it was worth like 10 horsepower. It's not because ported heads aren't good. They are. They work really well. but it's because the rest of the motor doesn't need that. So I would think it'd be more beneficial on a higher horsepower motor. 6-liter S475, L96, EFI, high ram. Don't mind a loss of low RPM torque. We'll pick a torque converter on boost response. Want a smooth idle. Shift around 7,200. Okay, yeah, that would be fine if you don't care about the low speed loss. I mean, an LS9 and that big and that T6 turbo are going to be soft down low. The LS9 will have a nice idle. It will make power. You know, it's a reasonable cam. It will make power at a higher RPM, let's say, than the other factory cams. But it's not going to make shift at 7,200. I don't know it's going to continue to make power out there, though. I could use some help with building my GT. It's a non-PI, like you said. It's better to have. I got fully poured heads you recommended. The only thing I'm confused with is the size cam. I don't know if what you're saying is that I somehow told you to get a non-PI. I wouldn't have told you that. What I would have said was, if you combine a non-PI factory short block with PI heads, that's a better combination than either one of the other two, because you get higher compression because you're combining the right piston with the right chamber volume. Hi, I know, but I know, I get it, but we can't go outside yet. We can go out later. And I'm hoping that you have ported PI heads, and then the camshaft that you pick is going to be dictated by what kind of RPM range you want to run. I have videos up where we tested all of the comp cams, and you can see what kind of power curve that you want. I heard through the grapevine that Coyote ARP heads work on a D16. Okay, I didn't know that. You be interested in doing a drag and drive? I do. Jimmy and I were talking about that, maybe doing that in his NSX. Been running 10-to-1 compression, 91. At what boost level will I need to switch to E85? Well, at any boost level, you would gain power with E85 because you'd be able to run more timing. Can anyone tell me a 50-pound GM flex fuel injector diameter fit in the early truck intake manifold? Yes, they do. I see you recommend an Extreme Energy 274, but I can't seem to find the right size you want of it. I don't recommend that camshaft. It's just a camshaft that I have run before. Quite honestly, I wish that I wouldn't have picked that for the thing that I built for my own Mustang. I wish I would have picked the 262 cams because they would have been a much better driver. But the Extreme Energy 274 H cam and not the AH cam, the H cam was the non-PI version, and I don't know if they're different now. And the AH was the PI version, which is the higher lift one. But they didn't have a 274 in the AH version. Here in SoCal, Trailblazer SS are a dime a dozen and cheap at $200 or $300. You can get them ported for $300, still cheaper than a fast. Yeah, it won't make fast power. It won't be anywhere near that, but it might be better. But it's not going to do, like I said, even a fast would gain more power on a more powerful combination. Why does a lower static compression ratio benefit boosted engines? It doesn't benefit boosted engines. The guys that are racing in class-specific things where they limit turbos and stuff run high compression with boost. The reason that people lower the static compression is because you're changing the detonation threshold. So that, especially, and this is particularly the choice of guys running pump gas. Coyote TVS 2.3 power curve versus Paxton curve. Give the same boost for quarter miles. I don't know that I've ever done a TVS 2.3 versus a Paxton, and I don't know what size Paxton you have. But it would be interesting to see because the Paxton would have a rising boost curve, but it also has a longer runner intake manifold. So the boost curve would definitely be a rising boost curve on the Paxton, and would be a slightly rising curve probably on the 2.3, although I don't know how high you're spinning that. You could get to a point where the 2.3 could run out of steam feeding the Coyote, depending on how much power you're trying to make. So you could have the boost curve roll over at the top maybe. But the 2.3 with a TVS would have a short runner intake manifold. So it'd be interesting to see what the power curve came out to be. Building a 6-liter LQ4, truck Norris cam, 317 heads, twin 68s, shooting for 600 wheel horsepower, putting in forged pistons, factory crank, running 91 pump. What boost level? Yes, you're going to need an intercooler if you're trying to run on 91. I think that those turbos are too big for the power output, because you can do that with one 68 millimeter turbo, the right one. 600 wheel horsepower. And it's good that it's LQ4 because the compression is going to be low, but you should be able to do that, I think, on pump gas. Plan on doing any cam testing in the future with Gen 5 motors? Yeah, I probably will go to BTR and test with them on that stuff. Here's to see the difference in aftermarket VVT cams versus non-VVT with the same spec. I don't know that guys will run well, I guess they could run non-VVT cams. What they do is end up running cams where you just have to get rid of the VVT. You can't run or at least that I know of, the only way to compare a VVT cam versus a non-VVT cam would be to run the same cam and then just don't advance or retard, just leave it fixed. Which that can happen when you get a big enough cam where you can't swing it because there's not enough available piston to valve clearance. So if you try to, that's why when they get to a certain size cam, they put limiters in it and then they put it locked in place. Already have a big cam and nitro 6-liter hot rod, just wanting the new turbo project to be a smooth driver and let the booster do the work. Okay. So, and how much power are you trying to make with that, Kyle? Because an S485 will be could be a lot of turbo. I think I missed somebody back here. Lower static compression. 274. GG Cole, are the turbos you sell Chinese? Obviously, they are from China. Our turbos, though, and I wish I could go into this in more detail, but our turbos are different than a lot of stuff that you see available online. And we were given a heads up about that from our suppliers. Having back pressure issues, but the bigger turbo has the same size air housing. I think it'd be okay. Let's see. Condition, what is that? What was your other question? I don't know what your other thing was. I got my Ripper cam the other day. I got a 5.3 on the stand tonight. Cam looks great. Thanks for offering stuff at a great price. We'll share an idle clip with you. Yeah, that would be good. The other interesting thing, this is very, very cool because we are continuing to do testing and I want you guys to get to good stuff. RichardHolderPerformance.com. Shout out to our store. But Jimmy ordered a hardness tester. So he was busy today and sent me a bunch of screenshots, and we were talking because we talk on the phone for hours. We're doing hardness testing on a bunch of different camshafts. And so I should be able to share that data with you later on. It's basically a surface hardness tester, but one thing it doesn't tell you is how the depth of the hardness, but we have had our cams tested for that anyways, and other cams too. And so we'll do more thorough testing on that. I'm curious to see how some of the other aftermarket cams, particularly some of the really garbage that's available out there, I want to do some testing with that and see what the results are. It'd be interesting to see. Pulling the heads off. 863 was asking around. Do you mean 862s? Anyway, eliminate the scroll ramp and casting node on the spark plug. Should I bother? Do you have suggestions for running 715 wheel horsepower? I don't think you should change the design of the chamber. Random question: how much heavier are cast truck manifolds versus the equivalent tubular headers of the same length? Just curious on weight savings. Well, a tube header like a shorty header versus a stock exhaust manifold, there is going to be a noticeable change in weight. Like picking up a cast iron stock truck manifold versus picking up a header, there's no comparison. I don't know what the number is, but it's a lot. Got my signed T-shirt. You're gonna frame it and hang it in the shop. That's awesome, dude. Is a BorgWarner 7686 T6 110 AR? Is that what did you have a question about that? Would injecting a small shot of nitrous into the air-to-air intercooler with a turbo be safe to run? Would be worth any noticeable gains? Any drawbacks? Well, I hope you're not thinking about it as an intercooling agent. You should be thinking about doing that as a power agent, because that's what it's going to do. And if you're going to inject it, you should inject it directly into the intake manifold, because that way it will add the power faster. It's not going to change the charge temperature. Almost nothing if you already have an intercooler. Too big for a Coyote. Danny, what kind of power output are you trying to do? We have really good Coyote cams. Jimmy's a big Coyote guy because he has a Coyote. He has a 17, 18, 19 Mustang, I think. Having issues a 76, 75, looking into a 78, 80. Both have a 0.96. Condition, let's start at the beginning. Tell me what kind of power you're trying to make. Everybody, when we're having a discussion, that's the first thing I want to know, especially with turbos. What kind of power are you trying to make? But even NA stuff. Tell me what kind of power you're trying to make, and then I can steer you in the right direction. Bone stock L33 with a GR35R cam. I max that turbo out. I don't know what a GR35R cam is. I'm not familiar with that designation. But with our GTX 3584 RS cam, that's about an 800 horsepower or so turbo. And it'd be harder to max that out with a stock cam. But with, like I said, with our low buck truck camshaft, you can max out that turbo. In fact, with our cam, with that low buck truck camshaft and a 5.3, you could max out the 1200 horsepower turbo, and probably something bigger also if you just keep turning the boost up. Does an LS need to be bored over if the pistons rock back and forth a bit when you hit the tops with the back of a hammer? There's going to be movement. There's going to be piston to wall clearance on every motor. And what's happening is probably the pistons are wearing and not the bore, because the bore doesn't wear very much in an LS. Are short runner intakes less fuel efficient at low RPM? Will they use more fuel to do the same work? I'm leaning towards they would, but one thing I don't know about is you might have to have more throttle angle for the short runner manifolds, and therefore less pumping losses under cruise. So I'd like to see a real test on that, and that's not something I can do on the dyno. I didn't realize that they're heavy. Yeah, stock exhaust manifolds are definitely heavy because they're cast. At 700 wheel horsepower, 800 wheel horsepower, it would be okay. Okay, condition. What is your motor now? I'm scrolling back to see what we got here. Just trying to make sure I didn't miss stuff. Sometimes I'm missing. 700 wheel horsepower is the end of the smaller turbo, and 800 wheel is definitely get the G42. Get our G42 turbo, and you can go up to 1200 flywheel horsepower. And it has a V-band exhaust. And for that size turbo, it's really responsive. What plays the biggest factor in piston to valve clearance, lift, or duration? Lift has almost no effect at all. Duration has an effect, and actually the valve event when it's happening. So if you have a long duration, and this is on the intake side on the LS, so the exhaust you can get away with 20 degrees more, certainly 15 degrees more duration. On the intake side, duration, and then LSA, like, you know, when you're opening it. What could you recommend cam wise for me to later add nitrous to and still have a really nice slope until I get that part of the kit? Want to make 350 NA and figure the 100 shot to be 450. Zach, what is your motor combination? Any camshaft works with nitrous. So pick the camshaft for what you want the camshaft to do, and then just add nitrous to that. Any here running speed engineering headers on a Silverado? Any clearance or fitment issues recommended, or is there a better choice for a little more money? Thomas, we're going to have something for too long here. We're going to be testing it pretty quickly. 6-liter sloppy stage 2. Yeah, that cam will easily get you there. It wouldn't be my choice for a driver, but I've installed a few sets of 99 to 13 trucks with no fitment issues, and have a set on my 14 L83 truck, and they fit great. On the speed engineering stuff, only issue is the band clamps they provide are not good. I cut them off and V-band them. Okay. They don't have V-bands on them. V-bands would definitely be the way to go. 700 wheel horsepower goal on an LQ9 with a turbo. What do you recommend for stock 317 heads? Valve springs are in mind for sure. Yeah, for 700 wheel horsepower, I would pick a I would pick the G42 turbo, because you're going to go up from there, and especially on the 6-liter. So you could pick this low buck truck camshaft. You could pick the Truck Plus, depending on if you want to do a converter and stuff. And then there are honestly, lots of camshafts that will do this. These are the two that we sell. You could even do it with a smaller ripper cam. Any of those camshafts will take you to 12, 13, 14, 1500 horsepower. They'll also idle good, and they'll be better things for a driver, and they'll be more responsive for the turbo. This low buck truck camshaft, that's 900. That's at 15 pounds. At 20 pounds, it's going to be 4-digit stuff. So it works fine. All of that's very easy to do. Take 317 heads. This had stock 799 heads. Same deal. Take the heads, put springs on them, put a camshaft like this that does the thing that you want for driving around and stock converter usage and all that, and then just add a good turbo. And out for your combination, I would definitely go with G42. Are you an aftermarket header test? I've already tested lots of aftermarket headers. What we're doing is building a setup for turbos for trucks. No, they're slip fit, not a good design. They leak. We use slip fit stuff as long as the slip fit section is big enough. Like we use those on the HP stuff Jimmy did way back on the 5-liter Mustang for the front, so that you don't have to have a bellows deal, and it worked much better because it allows a little bit of movement, but not enough movement where it would ever leak. I like V-banding stuff because that's what we do on the engine dyno. They have an option to buy V clamps, and I would do that on the header to the Y pipe side for certain. Yep. BorgWarner 7686 T6 110 AR, good for 850 to 1,000 wheel horsepower and 85. It's for a Gen 1 Coyote with a stock camshaft. Yeah, you could do that. I wouldn't pick a T6. Like I said, Danny, I would, if you already have that turbo, you can use it. I would pick our G42 for that. That's a really popular turbo for Coyote guys. How would a 5.3 stage 3 react to Hellcat supercharger? Looking for 700. It would be fine. All the cams would work with a supercharger too. And I don't know what stage 3 it is. Is it a stage 3 truck? Is it stage 3 NA, stage 3 supercharger, stage 3 LS1? An S485 T6 will light off at 4,500 to 5,000, maybe 400 wheel horsepower NA. Dynojet with an LS9 cam, maybe 800, 900 at 15 to 18 pounds on 93 mixed with 110. 2V non-PI, but I put max flow PI heads with it, and it's currently got a 78 millimeter bulk throttle body done, MSD ignition, so it's ready to get done. Just needs. I like the 262 cam. The other one will make more power. If you take a look at the videos I have up, it'll show you what the power curves are on all those and how much more power they make. I just didn't like the drivability of that 274 cam in my Mustang. It was soft down low, and I just didn't like that. For spool time, which one of your cams would you recommend? Definitely going with an upgraded converter. I would put it on a 6-liter. I would run a G42 because all the 6-liter guys are not going to want 600 at the tire. They're all going to want 800 at the tire. Richard Olden Performance working on launching new parts soon. Yeah, we are constantly doing development on stuff. We have wastegates coming in that we're testing. We have turbo stuff that we're working on. BBK throttle body, stage 3 truck, BTR cam, stock 5.3. Does it also need ring gap? Yes, you need ring gap, and I would not pick a stage 3 truck cam for that. If you have it already, certainly you could use it, but that would not be my choice. How do you develop your loading procedures for consistent runs with turbo engines on the dyno? You have to be really conscientious about putting heat in the turbo. So you figure out a procedure that is repeatable time after time without making any change before you make a change. So you have to, usually the second run on a turbo thing is the run that is consistent after that. Because you make a run and before you put heat in the turbo, like you could load it a bunch of times, load it, and then do a run. But that second run, after having made a full run, after that second run, then the motor's repeatable usually. And so you want to do that. But it takes some figuring out to make it consistent. With the 383 small block Chevy, Flowtech 200 heads, 224 cam, 224 to 232. That's a good one. Hydraulic roller cam for a good street engine. Any advice on the size of a single turbo for low boost? Looking for this in a C3 vet. Yeah, that's I would pick our 3584 because for that boost level, it's going to be real responsive on that motor. What are all the train tracks telling us? I'm just showing that's a G42 turbo at different boost levels on a 5.3. And I was just showing that if you look at the NA curve that's down lower, that the turbo with the right boost and the right timing and air fuel and all that just mimics that curve. And then we were talking about what do we do if we want to change where this thing makes power. We don't do that with boost. You can do it a little bit with a rising boost curve, but you do it with changing the NA curve. You make it have a shorter runner intake manifold and more cam timing. Pick an oddball S400 swap meet. It's an old S469, T483, 112 AR. Will this max out sooner than a standard S475 on LS, or is a turbine the limiting factor on the S475s? Does it have the same turbine as an S475? And how much smaller is the compressor side of that? I'm looking at a twin turbo setup, but not looking for max power. How bad is it to run a large NA cam with a bunch of overlap? It's not bad at all. It's just that when you run a big NA cam, you lose low speed power, and that hurts boost response. That's the biggest problem. The overlap is not an issue. The cam that you're looking at right here that's making peak power, at 6,100 or whatever, and making peak torque at 4,800 or something like that, and has 750 foot-pounds of torque down low, has overlap in it. And so overlap is not your enemy. What's wrong with it using the BTR Stage 3 truck cam with the Hellcat supercharger? There's nothing wrong with it. It's just not what I would pick. I just think that there are better choices. It will definitely work. And if it's a cam that I had, I would definitely run it with that supercharger because it's going to do the same thing. That cam in whatever combination you have is going to make some kind of power curve, and the Hellcat supercharger is going to add to that. The Hellcat supercharger actually is going to dramatically change the power curve, not because of boost, but because you're going from, if you ran it NA, you'd be running it with a truck or a Trailblazer SS intake manifold. And then when you put a Hellcat supercharger on there, that doesn't have very much runner length in it. So you're going to make power at a higher engine speed now with that. And let's face it, it's a positive displacement blower. So you're going to have probably, you know, all the boost down low that you want. And so even if that stage 3 cam is not ideal for low speed power, it's still going to be good enough. Specifically the GM Turbo Killer 2 cam. I don't know what that is. If you give me the specs on it, I can look at that and see. It's just not necessary with a turbo. You don't have to put a big cam in it like that. Like I said, this cam will go to umpteen horsepower, whatever you want to make. You don't need a giant cam in there. Building a 6-liter, 30 over, stock rod size, but stock rod size. I don't know what stroker size does that make. If you have a 6-liter that's bored 30 over, all you've done is added about 4 or 5 cubic inches. That's it. What is the purpose of priority main oiling on aftermarket blocks? You just don't want to starve the oiling for the mains. Is a CAS 69 comp wheel same 83 millimeter turbine housing as the T4S 475? Just curious if the 69 housing will limit me. It will if you try to max it out, but I don't know that you're trying to do that, right? I'm building my 2016 GMC Sierra into a pre-runner. I'm looking at 500 horsepower with wheels. Is there a way I can reach you to go over build options? This is the best place to do it. Are you trying to do it naturally aspirated? And what size motor are you trying to do it with? I'd like to see a comparison of video of different cams with measuring boost response. That would be good. But if you take a look at, and I would need to run this thing down at a lower speed, but if you take a look at the power curves of the motor, let's say at 2000 RPM with different cams, the one that has less power at 2000 RPM is going to have lower boost response. Smallest S400 I've ever seen, probably an old diesel application. That's part of the problem, is that those things are never designed for a lot of flow rate. Do a video on your Truck Plus cam under boost with a 6-liter. I think would be just fine for low end power, but curious on your input for sure. I don't know. I think when we were running boost on the 6-liter, I think we ran it with the Lobuck truck camshaft. Let's see here. Cathedral port, 6-liter. Turbo, file, test description. Yeah, we didn't run the, we ran the Lobuck truck camshaft in that and not a Trailblazer or a Truck Plus camshaft. But you can see what the difference is between the Lobuck truck and the Truck Plus. The Lobuck truck makes a bunch more low-speed power, and the Truck Plus makes more power above 5,000. You can see from these power curves that the boost just elevates that, just makes that, it's the same everywhere. So under boost, one of those would make more power below 5,000, and the other one would make more power above 5,000. How do you compare size-wise to a G42, a 7675? We ran a Precision 7675 in all of our testing and liked the G42 better. I look at turbos based on power output. A G42 is a 1,200 horsepower turbo. Very main oiling gets oiled to the main bearings before the cam lifters. Cam lifters don't really need as much. Yeah. Have you ever run a T4 log manifold where the driver's side crosses over, feeds, connects to the back of the turbo log manifold on the passenger side? Yeah, if you look at the video that I did on the Holley setup, that's what their manifolding is. They have a cast exhaust manifold on one side, and on the other side, and the exhaust feeds from that manifold over to the other side into the other double log, let's call it, because it's the exhaust manifold and the merge from the other side, and then they join together and then feed a single 3-inch V-band. That's essentially what it is. Stock motor, I'm not looking for supercharger or anything like that. It's still going to be my daily driver. Turbo Killer 2 cam, 237, 243, 112. This is what I plan to run, a 6-liter with a Pulsar twin 62s. I don't know why you would do that. I mean, that's a terrible choice for camshafts, but if that's what you want to run, that's fine. You don't need that size cam to maximize the power output to get to run those turbos. For you could max out those turbos with a camshaft that would be better in every way. It would be idle better. It would be smoother to drive. It would get better fuel mileage. It would have way better boost response for those turbos. It just would be better in every way. That cam will work if you want to run that. It's just going to be soft down low. It's going to have slow turbo spool up. You're probably going to want to put a big converter in it. You definitely should check available piston valve clearance with a 237 intake duration cam to make sure that it even fits. What is normal coolant pressure on a turbo LS? I just replaced head gaskets, check block surface, heads checked, but still getting coolant at the top of the cap. It's 0.9 bar cap, I believe. The turbo shouldn't change coolant pressure unless you're leaking boost into the coolant system. BTR is a bit aggressive for what I'm looking for. How about a low buck truck camshaft with the Hellcat supercharger? Yeah, you can see what a low buck truck camshaft does. The supercharger is just going to add to that. If you want to, are you trying to run this on pump gas? If you want to run this on pump gas and you want to kill some of the low speed power where there would more likely be detonation, then you could do that with a camshaft. Then you could go to an LS9 camshaft, and that's probably part of the reason why they did that. Would you recommend milling the heads on a 6-liter or leave it? I wouldn't do anything to them for boost. I would just make sure that they're straight and make sure that the deck surface of the block is straight. And then the turbo is going to decide all of the power output. Is it possible to build boost below the normal RPM required by removing of timing? Yeah, you can do anti-lag stuff, or you could size the turbo and the cam and the NA power output correctly. But you can do other things. You could two-step it. You can anti-lag it. You could do what are those things called? Dividing it halfway. What are the quick spool valves? You could do that. My dad's wanting me to cam his 2012 Denali. He doesn't want super choppy idle. Would you recommend a low butt truck or truck plus? The larger 6.2 will soften it. Yeah, it definitely will soften it over the other camshaft. That Ripper camshaft will have a better idle. It won't make the same power curve, but it will have a better idle than the low buck truck will. Don't know the specs, but a Stage 2 turbo cam 6-liter VSR T685 turbo would be a good combination. Swapping a T4 78 to an 85 currently. Yeah, all of that works fine. The Stage 2 turbo cam is like bigger than I like to put for a street driver because the response rate, especially with a T6. But I don't know what kind of converter you have and all that. Richard, your testing is an unbelievable gift. Thank you. I still hate exhaust side V-bands. So I found a way to weld them without leaks. Oh, okay. Yeah. Even a little bit of a leak, though. We don't care about that. At least on the dyno, we don't. On that note, though, it is time to go. We've been here a long time. We went way over. We went 15 minutes over. But remember, tomorrow, Jeff Smith, we're going to talk about the Callaway Sledgehammer Corvette. He's got the inside scoop on that. And then hopefully later on, we'll be able to get with Jeff and Carl and talk about the because Carl's the guy that designed all of this stuff, the compressed air supercharging stuff, which is very, very cool because it's like super chilly charged air temperature, which I like. I'll see you guys all tomorrow.